Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic bearings and vectors. The previous video was the last video on the first part of our topic, which is bearings. We are now going to concentrate on the second part of our topic, which is vectors. So let's learn more about vectors. A vector or vector quantity is any quantity which has both magnitude and direction. Examples are force, acceleration, etc. We learned in the video on bearings that bearings gives directions. For vectors, they give both direction and magnitude. So for example, if you take a distance bearing problem, bearings will give you only the direction, but a vector quantity will give you both the direction and the magnitude, which is the distance. Another quantity called the scalar quantity is a quantity that gives only magnitude but no direction. Examples are time, temperature, etc. In this video and the subsequent ones, we are going to concentrate on vectors. Just as we saw in bearings, vectors are also represented. Vectors can also be represented on diagrams. Vectors are denoted by a pair of block letters or capital letters and an arrow on top of them. For example, vector AB is written as AB with an arrow on top of it. So vectors are represented by capital letters or block letters. So vector AB is written as AB with an arrow on top of it. In the same way, vector CD will also be written as C, then D with an arrow on top of it pointing this way. Okay. What other thing can we learn about vectors? Vectors can be represented in two forms. The first one is the column or component form, where you have it in this way. So A and B. That is the first form. The second form is the magnitude bearing form, which is R and theta, where R represents the magnitude and theta represents the bearing or the direction. Don't worry if you don't understand most of these things. We will explain them as the video goes on. How do we represent vectors on diagrams, or how do we represent vectors graphically? We are going to consider for each case. So we will first consider for the column or component form. To represent vectors of the column form on diagrams, what you have to know is that A is measured along the x-axis and B is measured along the y-axis. So this one here, this vector here, can be written as if it is the coordinate of a point in the Cartesian plane or the xy plane. So when that happens, A represents the value on the x-axis and B represents the value on the y-axis. So A is measured along the x-axis and B is measured along the y-axis. So if you draw your Cartesian plane like this, or your x and y plane like this, with this point here as the origin, we know that this line here is our x-axis and this plane here, or this line here, is our y-axis. So if you have vectors in the column form written as AB, A, which is the first value here, is measured along the x-axis, and B, which is the second value, is measured along the y-axis. Now you can see that A here can be positive or negative. B here can also be positive or negative. If you draw the xy plane like this, we know that starting from this side here, if you are moving towards this direction, the values are positive. If you are moving towards this direction, the values are negative. If you are moving upwards, the values are positive. And if you are moving downwards, the values are negative. So if the x component, or A, is negative, move to the left. So what that means is that if you have vector in the column form, if A is negative, move towards the left. If A is positive, move towards the right. In the same way, if the y component is negative, move downwards. If the y component is positive, move upwards. So when you come here, if B is positive, move upwards. If B is negative, move downwards. These sign conventions are very important. We are going to use them a lot when we are representing column vectors on diagram. So this is how to represent a column vector on a diagram. Let's go to the second type, which is the magnitude bearing form. For vectors in the magnitude bearing form, that is r theta, theta represents the bearing and it shows the direction, while r represents the magnitude and shows the length of the line. So for example, this vector here given 3 kilometers 52 degrees. The magnitude or the length of the line is 3 kilometers and 52 degrees here represents the bearing or the direction. So what you have to do is that you measure or you draw a bearing for this 52 degrees, then you indicate the length of the line 3 kilometers on the line that you draw. Once again, we are going to take more examples on this, so you are going to get it very well. Remember that when you are drawing the bearings, all bearings are measured from the geographic north. Vector quantities are represented by arrow diagrams. So for the vectors that you'll be drawing, the lines that you will be showing will be arrowed lines or arrows. The length of the line represents the magnitude, and the arrows, the direction of the arrows shows the direction of the vector. So the length of the line represents the magnitude of the vector, then the arrow will show the direction. Thank you for watching this video. Don't forget to like and subscribe. In the next video, we are going to use the information that we've been able to obtain in this video, or what you've studied in this video, to represent vectors on diagrams. Bye bye.